Hi guys, my name is Ti Ting Yong. Today we will talk about the permanent magnet step motor. Are you ready for that? Let's start the lesson. Motor is a device that brought one of the biggest advancements in the field of engineering and technology since the invention of electricity. A step motor is an electromechanical device. It can convert the electrical power to mechanical power that driven by excitation pulse to the phase winding. The most common type step motors available in the market are permanent magnet stepper, hybrid synchronous stepper, and variable reluctance stepper. And today we will talk about the permanent magnet stepper. We choose the step motor is because the rotational angle of the motor is proportional to the input pulse. The motor has full torque at standstill. It has excellent response to sudden starting, stopping, reversing. The motor life is depend on the lifespan of the bearing because there is no contact between brush in the motor. The motor is simple and less control-free because it responds to digital input impulse, provide non-open loop. A wide range of rotational speeds can be realized as the speed proportional to the frequency of input pulse. The motor can be employed in the open loop control application. It has wide range of control frequency, is highly compatible with numerical control. But there is some disadvantage of stepper motor, which is it has relative low speed, low torque, and low power efficiency. The permanent magnet motor are shown in the figure 2. There are several parts like winding, mounting plate, the rotor, brushing and bearing, and even the connector. Winding is an encapsulated stator design given greater dimensional control and improved thermal characteristics. And the mounting plate have the custom and standard shape mounting plate. The brushing and bearing is the long life impregnated brushing are used in permanent magnet, PL which means screw lead screw type motor, and the MMB ball bearings are used in linear type of motor. The connector have the motor side connection method and the lead wire options. The schematic design of motor are shown in figure 3. The figure 3 shows a permanent magnet stepping motor consists of a stator with a winding and a rotor with a permanent magnet at the middles. Alternate rotor poles have rectilinear forms parallel to the motor axis. Stepping motor with magnetized rotors provide greater flux and torque than motor with variable reluctance. Motor with permanent magnet are subjected to influence from the back EMF of the rotor, which limit the maximum speed. The equivalent circuit are shown in figure 4. It has contain an inductor, a motor, and a load. The equivalent circuit, the RA and LA, represent resistance and inductance of air phase winding. Due to the large air gap introduced by magnet, the winding inductance of the permanent magnet or hybrid stepper motor can be considered to be independent of the rotor position. So now we talk about the working principle in detail. The stepper motors operate differently from other DC brush motors which follow their terminal voltage. The stepper motor efficiently have multiple tooth electromagnet arranged around a central gear-shaped piece of iron. Electromagnets are energized by an external control circuit, for example, microcontroller. The actual electromagnet must be powered so that the motor shaft, which make the gears on and off, the gears rotate slightly against the alien with the next one from there. The process is repeated. Each of the slightly rotation is called a step. In that way, the motor can turn by a precise. The stepper motor do not rotate continuously. They rotate in steps. The four coins with 90-degree angle between one each other fixed on the stator, which is 360 degree divided by 4. The stator motor connection are determined by the way the coils are interconnected. In step motor, the coils are not connected together. The motor has 60-90% 90 degrees step with the coil being energized with an cyclic motor. It determines the shaft rotation direction. The speed or torque of a permanent magnet type is changed by the number of poles used in the stator. If we want the speed to be increased, we will use a larger number of poles in the stator. If we want the speed to decrease, we just need to decrease the number of poles. A rotor is permanently magnetized. Hence, the movement of the motor is due to attraction and repulsion of the stator and rotor magnetic poles. In this motor, the direction is directly dependent on the direction of current flow in the winding, as the magnetic poles are reverse charging direction of the current flowing through the rotor. The permanent magnet motor uses a permanent magnet in the rotor and operates the attraction and repulsion. The external characteristics are shown as below. The electromagnetic torque produced by a two-phase permanent magnet motor is equal to the sum of the torque resulting from the interaction of the phase current and magnetic flux created by the magnet and the detent torque. The results are shown as and the equation are shown as below. The figure below shows a permanent magnet motor with phase A and B, and the table above is the phase switching sequence, which means 1, -1, 0 correspond with 2 positive, negative, and 0 phase of the voltage current when with different position. There are plenty of applications for the permanent magnet step motor. For the industrial machine, step motors are used in machine tooling, automated production equipment. For the security part, the new surveillance products for the security industry. For the medical, the step motors are used in medical scanner, samples, fluid pumps, respirators, and blood analysis machinery. For the consumer electronic parts, step motors in camera for automatic digital camera focus and zoom function, and also have the business machine application and the computer peripheral applications. This will be the reference for this lesson. Thank you for listening. Bye guys.